Okay, back to over here. So I'm just going to go back and recap all of this stuff. What we did is I redid this question by converting everything in terms of sine and cos. Tan theta is equal to sine theta over cos theta because of quotient identity. Cotangent theta is equal to cos over sine because of quotient identity and reciprocal identity. But don't forget, it's what I had to do is include that in each piece. So this compound angle I had to include. Now, we're going to manipulate the right side. So the right side is equal to, using the CAF rule, cosine pi over 2 times cos theta plus sine pi over 2 times sine theta all over sine pi over 2 cos theta minus sine theta cos pi over 2. So we need to find the values of cos pi over 2, sine pi over 2, and the same on the bottom. So we're using the graphs to figure that out, and we get 0 plus 1 times sine theta, and on the bottom you get 1 times cos theta minus 0. Well, that simplifies itself to be sine theta over cos theta. And lo and behold, if you look on the other side, wow, we have the same thing. So that means left side is equal to right side. We've checked, and that makes us happy. So this here is another one of the cofunction identities that you're given. You do not need to memorize these cofunction identities, but if you prefer to, you're more than welcome to. You can prove it, though, without having to know the cofunction identity. Let's move forwards. Example number 6. You're asked to prove sine theta is equal to sine theta plus 2 pi. Why? Well, think about it. This is going to be true always because when I add 2 pi, I'm adding the next period. But we have to prove this using the CAF rule. So let's prove this using CAF rule. So the CAF rule is going to be sine theta times cos 2 pi plus cos theta sine 2 pi. Well, cosine of 2 pi is going to be 1, and sine 2 pi is going to be 0. And this is what we get. And what does that result in? Well, that equals sine theta. So what I told you in the previous unit about being able to get this, now we can actually prove it using the CAF rule. Again, we take, if I'm giving you theta and I add 2 pi, well, I'll get back to the same arm that I originally had because we're adding one whole period, so we get back to the same place that we started at. All right, example number 7. Prove that the exact value of the following functions using CAF. Here's the first one, and here's the second one. With the first one, 17 pi over 12, we need to prove that the value is what it's going to be. Well, 17 pi over 12 is located in the third quadrant, and that will be 5 pi over 12. So cosine of 17 pi over 12 is equal to negative cosine of 5 pi over 12. Why did I do that? Well, I know that in this quadrant cosine is negative, and I know this is the related acute angle. So the value of this is equal to the negative of the related acute angle. How does that help us? Well, what is 5 pi over 12? It is equal to pi over 4 plus pi over 6. Why is that, you might be asking? One way to look at it is 5 pi can be broken up into 2 pi plus 3 pi. 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. 2 pi plus 3 pi over 12 is equal to 5 pi over 12. Let's look at another way to solve this. 5 pi over 12 is equivalent in degrees to 75 degrees. What is 75 degrees in terms of two special angles? To get 75, you need to add 30 plus 45. 30 degrees plus 45 is going to give us, right here, 30 degrees, which is pi over 6, plus 45 degrees, which is pi over 4. So the result will be, using the CAF rule, cosine of pi over 4 times cosine of pi over 6 minus sine pi over 4 times sine pi over 6. Again, the CAF rule for expanding cos is cos cos, sine sine, and we need the special triangles, so I use the special triangles. I draw them out here for you, and I use those drawings to be able to get my values. Cosine of pi over 4 is going to be 1 over root 2. Cosine of pi over 6 is root 3 over 2. And then sine pi over 4 is 1 over root 2. And sine pi over 6 is 1/2. All right, what do we do here? These are all our special values. Well, we have a common denominator of 2 root 2. In the numerator, we have negative on the outside and root 3 minus 1. Well, normally when you look at a question like this, you want to get root 2 on the top and the bottom. You want to multiply by root 2, our magic 1, because we don't want a root 2 on the bottom. Okay, at most, we're looking at a half-mark penalty with respect to this. So if you understand how to get here and you don't get to here, in most cases, folks, at most, on the whole test, we're looking at a half-mark penalty. All right, let's move forwards. Example number 8. Evaluate cosine of a plus b, where a plus b are obtuse angles. Sine a is equal to 3/5 and sine b is equal to 15 over 17. The key here is obtuse angles. What do we do here? All right, so what we can do is find the value of cos A. We know cos has to be negative because it's an obtuse angle. Both A and B are obtuse angles. So cos has to be negative in both cases. And then we find the tan value, but we don't need this tan value because we're valuing cos A plus B. So this, honestly, guys, is not necessary. So we could erase the tan. How did we get this -4, you might be wondering? Well, we have to use Pythagorean Theorem. Pythagorean Theorem, remember, is x squared plus y squared equals r squared, or remember that it's hypotenuse and all of that values. So we get that x is equal to 4, plus or minus 4, but we want the -4 because, again, we're looking at obtuse angles. Now we find the cosine of b, and we find out, using Pythagorean Theorem, that the value is -8. So, by expanding cosine of a plus b, you get cos A cos b minus sine A sine b, and we plug in the values that we found up here, folks, and we will get -13 over 85. Once again, cos A, we plug in cos A for this. Cos B, we plug in this value over here. Sine A, we plug in 3/5. And sine B, we plug in 15 over 17. Total, the denominator is going to be 85, common denominator. And the numerator is 32 minus 45, which gives us -13. All right, that's the end of this lesson, folks. Have a great night. Take care.